All right, here's the practice sheet that goes with the lesson I just did on zeros and multiplicity. So let's, the hope is that you practiced first, and now this video is here to support you if you need some support. So the first step is to factor this and then find the zeros. They don't want us to find zeros and multiplicity. That's on the back side. So how do I factor this? What's there in common? In this case, it's x. And then the next step is, can you factor that? It's important to know that 6 is positive. So we're adding up to get to 5. So it's going to be -2 and -3. So it adds up to -5. And that means the zeros, a monomial, just an x, means it's 0. And then +2, and then +3. Number 2, can you factor this? Step 1, what do they have in common if there's something? So I see 2 and an x. So divide by 2. So 2 divided by 2 leaves me with x squared. 22 divided by 2 leaves me with 11x. 56 divided by 2, half of 56, 28. Can you factor a simple trinomial? Two numbers that multiply to 28 and add to 11. So those numbers are 7 and 4. So 7 times 4 is 28, and they add up to 11. Order doesn't matter. And now that it's completely factored, you can tell me the zeros. So the monomial in front with the x, it's 0, then -7, and then -4. This is the trinomial to begin with. They have nothing in common. So we go right to what two numbers multiply to 16 and add to -17. So -16 and -1, they multiply to +16 and add to -17. Notice I used x squared instead of x. That's because I divided it by 2. X squared times x squared gives me x to the 4th. That way it matches. Now there's another step here. This is a difference of squares. The square root of x squared is x. The square root of 16 is 4. So it's +4 minus 4. The next one, the square root of x squared, and the square root of 1. So +1 minus 1. Now that it's completely factored, we can see what our zeros are. So you have positive and -4 and positive and -1. Number 4. Is there anything in common? Yep, there's a x. There's in common. That's it. That leaves me with 2x squared plus 5x minus 7. If I'm going to do this, this probably is more helpful to draw a diamond to organize it. 2 times -7 is -14. And 5. Two numbers that multiply to -14 and add to 5 are 7 and -2. Come back to the function. Take out the 5x and put in 7x and -2x. And now we're going to factor by grouping. So the first two terms, 2x squared and 7x, they have an x in common. That leaves you with 2x plus 7. The next two, -2x and -7, I factor out a -1, which then again gives me 2x plus 7. Notice they match. That's what we need. So we have x. Inside we have 2x plus 7, and that leaves me with x subtract 1. There it is, completely factored. So then what are the zeros? The monomial in front gives me 0. The next one is not -7, but -7 divided by 2. The next one is +1. Number 5, can you factor? So they have an x in common. That's 6x squared plus 7x minus 5. Again, I recommend you to try this first. Press pause and try it, and then come back. Okay. So 6 times -5 is -30 with +7. So what two numbers multiply to 30 and subtract to 7? So that's 10 and -3. Come back here. Take out the 7. Put in 10x and -3x instead of 7. So I took out the 7x and replaced it with 10 and -3. Now factor by grouping. what do they have in common? So 6 and 10 have 2x in common, and what's left over is x plus 5. What's a 3x plus 5? 6 divided by 2 gives me 3x plus 5. Factor out a negative 1 and you get 3x plus 5. And then it's done factoring. So we have 3x plus 5. And then what's left over is 2x minus 1. So what are the zeros here? So the first x, the monomial, gives me 0. Then we have negative 5 divided by 2. Then we have positive 1 divided by 2. Factor out what they have in common. In this case, it's a negative x. And what leaves me with is 3x squared plus 13x plus 4. If I drew a little diamond to organize it, 3 times 4 is 12, and 13 underneath. The two numbers are 1 and 12. They multiply to 12 and add to 13. So what's in front? We have negative x, and then I have, take out the 13x, and put in 1x and 12x in its place. Then factor by grouping. So the first two only have an x in common, and you have 3x plus 1. The next two have a 4 in common, and you're left with 3x plus 1, which is what we want. And so the last step then is the 3x plus 1 we factor out, and we have still x plus 4 after that. The zeros. So negative x, the monomial, gives me 0. The next one, it's not negative 1, but negative 1 divided by 3. And the last one's negative 4. Number 7. This is a trinomial. So they have nothing in common. 4 times 1 is 4. And negative 5. So the two numbers that fit are negative 1 and negative 4. Come back here. Take out the negative 5x and put in negative 1. Order doesn't matter. So negative 1 and negative 4.
Please come to the activities office. Jesse Diaz, Robert Cesenia, Adrian Sanchez. Please come to the activities office. Adrian Sanchez, Robert Cesenia, and Jesse Diaz. Activities office.
Our bells are way off today. All right. So let's factor what they have in common. So the first one is an x squared in common. That leaves me with 4x squared minus 1. The next one has a negative 1 in common. And that gives me 4x squared minus 1. So that when I put it together, I have 4x squared minus 1 and x squared minus 1. Both of those are a difference of squares. So the square root of 4x squared is 2x plus 1 and 2x minus 1. And then we have x plus 1, x minus 1. So what are the zeros here? Positive and negative 1 over 2. And positive and negative 1. Number 8. Factor out what they have in common. So what they have in common is a 4x squared. Divide, that gives you x squared plus 20x. 204 divided by 4 is 51. Now factor what's left over. What two numbers multiply to 51? And add to 20. So those numbers are 17 and 3. So 17 plus 3 is 20, and 17 times 3 is 51. Now you can tell me the zeros. So the monomial in front gives me the answer 0, and then negative 17, and then negative 3. Number 9, can you factor it? So this is going to be done by grouping. We have 4 terms. So look at the first two terms. They have a 4 and an x squared in common. That leaves me with x plus 4. The next two terms, negative 25 in common, divide. That gives me positive x plus 4. So we have the 4x squared minus 25 and the x plus 4. 4x squared subtract 25 is called the difference of squares. So the square root of 4 and x squared is 2x, and the square root of 25 is 5. So 2x plus 5, 2x minus 5, I'm going to continue here, and then x plus 4. There it is. So what are the zeros? So we have positive and negative 5 over 2, and then negative 4. All right, last one. Again, we're going to factor by grouping, so I'll start up here. So they have an x squared in common, that's 3x minus 1. Here you have a negative 4. That gives me 12. Negative 12 divided by negative 4 is positive 3x. Negative 4 divided by negative 4 gives me negative 1. So now we're set up where we can group them together. So what do they both have in common? 3x subtract 1. And what's left over is x squared subtract 4. We have a difference of squares. So the square root of x squared and the square root of 4. So we have plus 2 and minus 2. And there you go. So what are your zeros then? It's not just positive 1, but divide by 3. And then you have the 2 that go together, positive and negative 2. All right, turn the page. Here is find the zeros and state their multiplicity. So again, we're practicing factoring. So what do they have in common? The only way we get stronger is by practicing correctly. So factor out an x. What two numbers multiply to 49 and add to 14? That's 7 and 7. So we write it as squared. So what's the zero and the multiplicity? So the monomial is 0. And the multiplicity, I'm going to use the word odd. So can you see the multiplicity is 1? Underneath we'll do 1, odd then. So it has a multiplicity of 1. And the other one is negative 7. And it has a multiplicity of 2. Remember, the multiplicity comes from the exponent on the factor. Okay, so next up, factor. So we factor out an x squared. And then think, what's left over? What two numbers multiply to 81? The same two numbers add to 18. That's 9 and 9, so we can square it. And then again, the zeros in multiplicity. So x squared, it's just 0, but it has a multiplicity of 2. And then negative 9, and it has a multiplicity also of 2. Here, factor out an x, you get 4x squared minus 4x plus 1. So 4 times 1 is 4, and negative 4, that's negative 2 and negative 2. So I'm going to take out the negative 4 and replace with negative 2 and negative 2, and then factor by grouping. So the first two have a 2x in common. The next one just has a negative 1. What did I do wrong here? Oh, this should be at 2x minus 1. If you divide, take out a negative 1, you get 2x minus 1. They weren't matching up, so I looked back to see I divided wrong. So we have an x, and then we have a 2x minus 1, and then what's left in front, again, is 2x minus 1. So we could write it as x and 2x minus 1 squared. So what are the zeros in multiplicity? So 0, and the multiplicity is 1. That's the exponent on x. And the other one is positive 1/2, and it has a multiplicity of 2. Because the exponent is 2 on there. Factor this by grouping. So they have an x squared in common. Here a negative 1 in common. notice that we have a common factor of x plus 5 and then x squared minus 1. X squared subtract 1 is called the difference of squared, so it's written as x plus 1, x minus 1. If I wrote down the zeros in multiplicity, negative 5 has a multiplicity of 1, and positive and negative 1 also have a multiplicity of 1. Factor. So look, what do they have in common? They all have at least two x's, so x squared. What's left over? 36x squared minus 37x plus 1. So if I factor this, I'll do it way on the side here, so I have room. 36 times 1 is 36 and negative 37. The two numbers that fit are negative 1 and negative 36. They multiply to positive 36 and add to negative 37. So we have x squared, 36x squared, and then replace the negative 37 with the negative 1x and negative 36x. And now we can factor by grouping. So we'll group the first two. They have x in common. That gives me 36x minus 1. The next one have a negative 1 in common. That gives me 36x minus 1. So if I group these together, I have 36 what we got here? I have 36x. What did I do? This is just a simple trying to, right. 36. So negative 1x and negative 36, they have an x in common. I get x minus 36x minus 1. And what's left over is x minus 1. What do I get? You get 36x squared minus x minus 36 plus 1. That's what I get. So what are the zeros in multiplicity? So for x squared, it's 0, and the multiplicity is 2. Then I get positive 1, and it has a multiplicity of 1. And I also get positive 1, but it's divided by 36, and it has a multiplicity of 1. All right. Sixteen. Factor out what's in common. So they have an x cubed. They all have at least 3 x's multiplied. Divide, that gives you x squared plus 16x plus 64. What two numbers multiply to 64? Add to 16. That's 8 and 8. So I just write it as 8 squared. So the zeros in multiplicity, 0, and it has a multiplicity of 3. Negative 8, and it has a multiplicity of 2. Number 17. Same kind of question, but just understanding what effect it has on the graph is the extra part, whether it touches or crosses over. So it's factored form. So the first factor gives me a 0 of 2. The exponent is even, which means it's going to touch the x-axis. The next factor, it's not negative 7, but negative 7 divided by 3. It has an odd exponent, so that means it's going to cross the x-axis. The last factor, it's not positive 3, but positive 3 divided by 4. It has an even exponent, so at 3/4 it would touch the x-axis. Number 18. The monomial in front is just 0, but it has an even exponent, so at 0 it's going to touch the x-axis. The next factor, positive 9. The exponent you don't see on the outside is odd, so it's going to cross the x-axis there. And then it's not negative 5, but negative 5 divided by 2. It has an even exponent, which means it's going to touch the x-axis there. So we have an x cubed, that's x squared plus 6x plus 9. This is a perfect square, so what numbers multiply to 9 and add to 6 are 3 and 3, so we write it squared. So x cubed gives me the 0, 0, and as an odd multiplicity, because the exponent's odd, which means at 0 it's going to cross the x-axis. The next factor gives me the 0 of negative 3. It has an even exponent, so at negative 3 it's going to touch the x-axis and not cross over. Alright, last one for practice. Factor out what they have in common. So what number goes into 8, 24, and 18? I think that's just 2. And they all have at least an x. So that leaves me with 4x squared. That leaves me with 12 x, and then 18 leaves me 9. So if I look and see what's left here, 4 times 9 is 36 and 12. So the two numbers that add up to 12 and multiply to 36 are 6 and 6. This tells me it's a perfect square because the number repeated. Now it's not going to be plus 6 plus 6, but we're going to use 6x and 6x to figure it out. So we have 6x and 6x. So if I factor out, I'll do it right here, what they have in common. They have a 2x in common, and then divide, and you get 2x plus 3. Factor out what they have in common. They have a 3, and you're left with 2x plus 3. So if I put it all together, I'll do it down here. I have a 2x in front, and then I have 2x plus 3, and what I'm left over with is 2x plus 3, so I square it because it repeats. So we have a 0, that's the monomial, with an odd exponent, so it's going to cross. And then the other one is not negative 3, but negative 3 divided by 2. It has an even exponent, so that means it's going to touch the x-axis. All right, good job practicing. I'm proud of you. It's not easy, but as we practice, we get better. Good job. Mr. GMAT, over now.